Hello everybody, in today's video we're going to be going over the third and final part of this winter discussion. We're going to be talking about the PNA, the NAO, the AO, and the EPO, all the oscillations which really have a big factor on the winter. And these are different things that can impact the winter, and we're really only going to know what's going to happen with them as we get within about a month or just a few or a couple weeks of that event. So we're going to have to wait a few more weeks, a few more months to actually figure out what's going to happen with these oscillations during the winter. But I do want to talk about what they would mean if they were in a positive or a negative phase. We'll be discussing that a lot in today's video. And again, this is the third and final part of our winter discussion series for the late September time. As we get into mid-October, they're going to put up another ENSO outlook. So I'm assuming I'll probably have another set of winter discussions out for then. So each time that they update the ENSO pattern outlook, that's when I'll put up a new winter discussion. But for right now, we're going to keep it at 3 with this, and then we'll move on to either talking about the tropics, because there is something kind of brewing up in there, or we'll probably talk about the temperature pattern in the United States afterwards. So we have a ton to get through in today's video, so make sure you are staying tuned all the way until the end, and let's get right into it with the PNA. So this is what a positive PNA would look like. And if you don't know, the PNA is basically an area over the Pacific and also North America. So it stands for Pacific North America Index. It's basically for right within this region. So it's within Western North America, also into the Eastern Pacific. And it talks about basically how warm or how cold the temperatures are within that region. When you have a positive PNA, typically that's going to indicate this is the average temperature anomalies in a positive PNA. Usually it does mean that you have rather warm temperatures throughout Canada and also the northern plains as well as the western United States, but it does really open up the option for colder temperatures into the eastern United States, the southeast, and the southern plains. So if you live in that region, you definitely want to be rooting for a positive PNA. A negative PNA would mean that you would have a trough into the west, and then you would have a ridge into the east. So if you like the warmer temperatures and you live in the eastern United States, you would want a negative PNA. We've seen that in past winters that have been snowy. Most of the snow comes within a positive PNA, but the positive PNA is not going to be the only determining factor. You're going to need a few other oscillations to really match up with each other, such as the EPO. The NAO is a big one that a lot of people like to talk about, and I think one that's underrated is the AO, the Arctic oscillation, as well. We're going to look at all of them in today's video. So here's a look at the precipitation anomalies in a PNA pattern, a positive PNA pattern. You usually see quite a bit over some of southern Alaska in the mountain ranges over there. And then we have drier conditions for much of the United States, especially the Ohio Valley and the Tennessee Valley, as well as the Northeast. But just because it's drier does not mean necessarily that you're seeing a lack of snowfall. What we know is that in most snow events, you're dealing with much less actual liquid precipitation as you would get in a rainstorm. So, for example, in the Tennessee Valley, if it's colder than normal, and let's say you get a snowstorm and it drops 5 inches of snow, you're only looking at about half an inch of liquid precipitation as the equivalent in an average snow event of that size. But if you were to look at a rain event, that same event would probably drop about an inch of rainfall. So we're only looking at the total amount of precipitation, not necessarily the snowfall. And snowfall, we know, of course, has a lesser amount of liquid within it. So again, 10 inches of snowfall, the average is that would equal out to 1 inch of rainfall. So you can have a really snowy winter and still technically be below average in the amount of precipitation, because snow, if you have a ton of it, it's not going to really be the same. It's not going to have the same liquid equivalent to rainfall. So on a spreadsheet, if you were to look at it, most of these winters with positive PNAs would be below normal, but when you're looking at the snowfall, that would end up being above normal within these areas. So you're looking at this and you see, wow, it's way below normal for the precipitation, but in reality, most of that would be coming in the form of snowfall, so it's going to look below normal just because it's not as much liquid equivalent, but it would still be quite a bit of storms moving through those areas. Let's now talk about the NAO, which is a really important index. It's the North American Oscillation, or the North Atlantic Oscillation, and this is basically looking at the area south of Greenland, so right here. And when you have a negative NAO, what that basically means is that you have low pressure south of Greenland, and that can cause some high pressures to build up into northern Canada and Greenland. So that would mean that your colder air, which was originally in the Arctic areas, is now displaced into the United States. And you can see that in an average negative NAO, you have much colder temperatures into the eastern United States, southern Canada, and into the northern plains. Usually when you have a positive PNA, it does correlate with a negative NAO. And again, some of these oscillations are going to come together in a lot of ways. So it's not very unusual. It's not very rare to have a negative NAO and a positive PNA. They kind of go hand in hand. So it's which one are we going to get? Are we going to get a negative PNA and a positive NAO, or are we going to get the opposite, which would be a snowier option for the east if we had the negative NAO and the negative or the positive PNA? So just because you have one that's negative does not mean that the other one isn't going to be in that favorable position for colder or snowier conditions. Again, they usually correlate with each other. It's not really, they're not really that disconnected from each other. And the NAO is really a big player into the winter. You're going to see a lot of people start to mention the NAO. But again, the problem with these oscillations is that we can't really track them until we're within a few weeks of them. So these models, so the furthest out one of the models that I found was 35 days from the GFS model, and even then it does become quite inaccurate after about 2 weeks. So you can't really forecast this 3 months in advance. So I'm just showing you this information, showing you that if we get into this pattern, that would mean colder temperatures for the east, but not necessarily guaranteeing that we will be in those colder temperatures, or that we will be in that colder pattern. And it's going to be all up to chance on really whether we actually get into that pattern. I think looking at these oscillations, long term is not really that important. We're not going to see any real correlation between what the NAO is now and what it is 3 months from now. But I think it is definitely in the short range much more important to look at than really any sort of long range data where you're looking at, well, we're in a La Nina, so that would mean that probably it's more active in the northwest. I would say you're probably going to be better off looking at shorter term indices while we're already in winter, such as the NAO, the PNA, EPO, things like that. Here's the AO, the Arctic Oscillation. This is a very, very important one, and I think a lot of people don't really look at this too much, and it's a shame because it really is a very important oscillation that is very, very crucial into how the winter ends up playing out. So here's what it typically means. In a negative AO, this would be what we would want if you want colder temperatures and you live pretty much in the eastern half of the eastern third of the country, or in the western third of the country as well. If you live right in the middle in parts of the northern plains, it might be a little bit warmer than average, but still, this is basically showing that in a negative AO, that's where your cold air from the Arctic would be getting displaced. So that colder air, which was over the Arctic regions, now is shifting all the way into the United States. And that's typically what a negative AO means. And that's the more favorable one for cold and snow. But in a positive AO, pretty much the entire United States would average out to be a little bit warmer. But you typically have more of a compact, tight polar vortex that just sits there, really doesn't do anything, and it might make the Arctic regions extremely cold. Greenland might be running 20 degrees below normal, but the United States, we're going to be in a bit of a milder pattern if you have a positive AO. And with a positive AO, you can really not get too much done. Even if you have a positive PNA, which the PNA, NAO, AO, I think are the most important three oscillations. The EPO is less important, but you still want to look at it. But those three are the main ones, and I would say the NAO gets a little bit too much coverage when the AO is what you should really be looking at, because the AO is going to determine whether we have a compact system up in the Arctic Circle or whether it's a little bit more loose, like in a negative AO, where you would end up having some of that colder air spilling further to the south. We saw in 2019-2020 where we had something really compact polar vortex, and it was a very warm and mild winter. But then you go into 2020 and into 2021, and we see the opposite, where the polar vortex kind of got unleashed into January and February, and that brought in the colder temperatures. So we were in a positive AO for much of these less snowy winters, and then once you get into a snowier pattern, typically that's going to have a correlation with a negative AO. Here's also the East Pacific Oscillation. So this would be what a negative East Pacific Oscillation would look like. The EPO and the PNA typically have a fairly close correlation because it's covering a very similar geographic area. The EPO is more out for this area right here, so it's more out to sea. It's not really covering North America as much. The PNA covers this area a little bit more, but both of them cover a fairly similar part of the Eastern Pacific. So if the EPO is in a negative phase, then you're probably dealing with a positive PNA. It somewhat has that type of correlation. What that would typically mean in a negative EPO would be that you have ridging up into the Gulf of Alaska. So you would have milder conditions out there, and that amplitude up into Western Canada and into Alaska would allow colder temperatures to spill into the United States, because like we were talking about before, the further north that high pressure is, the more strain that's putting on the jet stream, the bigger the dip down on the other side will be. So if you have a really drastic high pressure moving to the north into northern Alaska, well, you're going to have the same and opposite, the exact opposite happen over the areas just east of there. So you would have a big dip in the jet stream just to the east of that big high pressure. So that would enable colder temperatures into the United States. And if we look at what a positive EPO would look like, you would have low pressure into the Gulf of Alaska, and you would have the cold air being able to just stay up there because there's nothing pushing that cold air away. You're just having this low pressure kind of sinking to the south. You have you have the jet stream staying straight across the Pacific, which you want to make sure that you're looking at the jet stream over the Pacific as well. If it's in a straight line, that's really going to be not so good of a sign for cold and snow. When you have that jet over the Pacific just being pretty much straight, again, that's not really a good sign. You would want to see a little bit more of a wavy jet stream to have some colder temperatures and some snowier conditions. And because you have this low pressure down here, it's not really impacting the Arctic regions. You have no real reason for the Arctic cold air to be pushed further south. So you're just going to end up with milder and warmer conditions over the United States. And that's typically what would happen in a positive EPO. Although, again, even if you are in a positive EPO, even if you are in a negative PNA, the opposite can still happen. Even if you're in, again, a positive PNA or a negative EPO, the opposite of what typically happens can still happen. It's definitely nothing that's set in stone. And just to look at what we're expecting going into October, if any of you guys are interested, especially for the fall foliage, this will have an impact because it'll show whether it'll be colder or not. We are going into a negative NAO, so that might be a sign of some correlation between that and some colder air. Usually the oscillations aren't really going to have a big impact in the summertime. It's going to be more in the wintertime when they start to show themselves a little bit more, and when they would have more kind of say on what the weather pattern will be. If you look at the Arctic oscillation, that is well into the negative category as well, so that would seem to indicate some amount of colder temperatures into the United States. If we look at the East Pacific Oscillation, this one's also going negative, so that would seem to be somewhat of an indication of some colder temperatures. It was really throughout much of the summer in a fairly positive stage, almost 3 or 4 standard deviations above the mean. So we're going back into a bit of a more of a regressive pattern where we're going into potentially a negative or neutral EPO. And then if we look at the Pacific North America index, you can see that we're having some of those temperatures maybe dipping down. We're going maybe into a bit of a below normal PNA or a negative PNA, and then we skyrocket back up into a positive PNA after that. Now again, this is all for the short term. You can see this only goes out 10 days. So again, these are really short to medium term things that you want to look at. We're not going to be able to forecast that out 3 months in advance. The most we can really realistically do and still have some accuracy to it would be 14 days out. So really nothing that you want to look at this far out, but you do want to be aware of what each one would mean. So that's what really the purpose of today's video was, to really give you an understanding of what each one is. And when you start to hear that term being pushed around, and I'll definitely be using some of those terms because they are important to the weather forecast, such as the positive PNA, negative NAO, all that. When you start to hear that kind of lingo being talked about in the weather spaces, you want to know what that means. So hopefully this was able to break that down for you guys. Hopefully you guys were able to get a little bit of a better understanding of what all those terms mean, because you will again hear that tossed around a little bit, and it will have a big implication on the winter time. So if you have any questions or comments, leave a comment down below and I'll be responding within a few hours of you posting that, and I'll see you guys in the next video. Goodbye.